In this problem, we're asked to find the eigenvalues of the matrix B, which is a 3 by 3 matrix here. And we just remind ourselves that the eigenvalue condition or equation is that the determinant of, here it's B, minus lambda I has to equal 0. We have to have this matrix be non-invertible, and that implies having a determinant of 0. It collapses something. All right, so let's figure that out. This is the determinant of B minus lambda I. Now this is a 3 by 3 matrix, so we're going to want to be a bit more sophisticated about our construction. But what we also need to do is include the minus lambda i's. So what I would do for this is I literally copy out the matrix 0, 0, 4, and then we put down the diagonal, because the I matrix, the identity matrix, is just ones down the diagonal only. And then we multiply that by minus lambda. This would be our matrix B minus lambda I. This matrix with minus lambdas down the diagonal. Of course, we don't want the matrix, we want the determinant of the matrix, so we do our little extension here, copying the first two columns. This is our shortcut for 3 by 3 matrices, and now we're ready to go. Determinant of B minus lambda I is going to equal these diagonals, so that's a long one. There's always going to be one of these expressions at least, where you have a whole pile of lambdas in the determinant. We're going to have that, and the next diagonal is 0, and the next diagonal product is 0 as well, minus the upwards paths, that's 0. That product is 0. On 0 too. Whew. It's like we picked this to be simple for your first 3 by 3 example. So we get, just tidying all this up, 3 minus lambda, 2 minus lambda, 4 minus lambda. Now in this case, we still need to set that equal to 0. But what happens here, what's different, is it's already factored. If we'd had other terms, this would be a messy cubic to solve, but here we already have the factors solved for, so we get lambda equals 3, lambda equals 2, and lambda equals 4 are the three eigenvalues for B. And again, what does that tell us? So just keeping in the back of your mind, so B scales a direction, one direction by, let's call it one direction by 3, a second direction by 2, and a third direction, some other vector in 3 space, by 4. Remember, we're trying to encapsulate what this matrix does, and we're most of the way there, or we're halfway there really. We've identified what scaling factors it's going to apply, and now we just need to figure out, well, what direction gets scaled by 3, what direction gets scaled by 2, and what direction gets scaled by 4. That will be our next step, which is finding the eigenvectors that go with the eigenvalues.